Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving maximum value of an ordered triplet 1. So the problem states that we are given a zero index array called nums, and we want to return the maximum value over all triplets of indices, I, j, and k. And I will always be on the left, j will always be in the middle, and k will always be on the right of the triplet. And if all of the triplets combined together have a negative value, then we want to return 0. And the value of a triplet of indices I, j, k will be equal to the nums of I minus the nums of j times nums of k. So if you look at this example, the largest triplet that we can make is 77 because we can do 12 minus 1, which is 11, times 7, which would be k on the right, and that would be equal to 77. In example 2, we can see that we can put 10 as I, 3 as j, and 19 as k. So 10 minus 3, which is 7, times 19 will equal to 133, and that's the largest value that we can make. So we will return 133. And in the third example, the only triplet that we can make is 1 on left, 2 in the middle, and 3 on the right, and 1 minus 2 times 3 is equal to negative 3, and that's a negative value, so we'll just return 0 instead, since all the triplets have a negative value. So now that we have seen some examples, let's get to how we can solve this problem. So there are many ways that we can solve this problem, but the brute force way to solve it is to check every single possibility. So we will iterate through each I, and for each I, we will iterate through each j, which is the middle value of the triplet, and for each j, we will iterate through each k, which is the right value of the triplet. And as we can see, after each time we iterate through all the values, we will calculate the result that we can make, and we will keep track of the maximum one that we can make, and then return result in the end. If we do this approach, since it's a triple nested for loop, it will take O of n cubed time. So there are more efficient ways to solve this problem, so let's go over them right now. So a slightly more efficient way to solve this problem would just to have to iterate through each k and each j. So at each k, we will start at index 2, and then we will also iterate through each j from 1 to k minus 1 inside the k's. And instead of iterating through each I, we will just keep track of the I as the max prefix. So max prefix is on the left. So instead of just keeping track of the result as the previous approach, we can keep track of the left index and the max result. So that way we can save one extra for loop, so we can make it O of n squared. So as you can see, at each iteration in the beginning, we will set the max prefix to all the way on the left. And as we iterate through j from 1 to k, we can update the max prefix as we iterate along through j. So this approach would be O of n squared time, but there's still another more efficient way to solve this. So let's go over that way right now. So an even more efficient way to solve this problem, to make it linear, is we can set up a left max and a right max array. So the left max array will represent the largest possible value of I at that index. The right max array would represent the maximum possible value of k at the certain index. And we will only have to iterate through j, the middle index, and we will pair it with the left max and the right max at that index. As we iterate through j and we calculate the value, if it happens to be bigger than what's at the result at the time, then we can update the result. I'll go over how to set up the left max and the right max in the coding section, so you can wait for that. It's pretty simple, but let's go over this example right now. So first, we set up the left max and the right max, and now we need to iterate through j. So at 10, we will set j to 10. 1 is the maximum we can make on the left, and k would be 19. That's the maximum on the right. The total is 171. It's less than 0, so we don't update it, and we go to the next index. Now at 3, we will set j to 3. 10 is the maximum value of I that we can have, and 19 is the maximum of j. So 10 minus 3 times 19 is 133. So we can update the result to 133, and we can move on to the next index. Now 4 can pair with 10 and pair with 19 at that position. So 10 minus 4 times 19 is 114. It's not greater than result, so we can just keep the result as 133. And we don't need to check 19, because if j is 19, then there will be no available value for k. So we can stop at the second to last index. Therefore, we can return 133 as our result. So the time complexity would be O of n, because we only have to iterate through j, so it would be linear. And the space complexity will also be O of n, because the left max and right max array may take up to O of n space. So now let's get to the coding part. So first, we will initiate the left max array to 0 times length of nums. And we will do the same with right max. So right max is equal to 0 times length of nums as well. And now to set the values of them, we would loop through from index 1 to length of nums. And the left max of I would be the max of the left max of I minus 1 or the nums of I minus 1. So that's how we calculate the left max. And for the right max, it would be the length of nums minus 1 minus I, because we are calculating it backwards. And then it would be the max of the right max of length of nums minus I, or nums of length of nums minus I. So basically at each iteration, we are either updating the value from the nums array or keeping the value from the previous value in left max and right max. And now we can calculate the result. So result we will just do for j in range 1 to the length of nums minus 1. And we will set the result to the max of result, or if we can find a larger one, the left max of j minus nums of j times the right max of j could be our result. So the max of the two. And then we can return result after iterating, see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave down in the comment section. And I hope to see you all again soon.